sure.
J'essaie des cours.
Actually, I'm not really interested.
You all right?
Video, but I don't know what full task.
Yeah, fine.
But you are done now? I mean,
Better than the laptop's already connected.
This isn't my laptop.
I did it already before, but maybe I just this one so I can
You've got big avatar now. Big avatar now.
I would like to try to contact Sebastian because he insisted that I should do this.
That you should
but
do video?
There's nothing to do, so
To try to call him on.
yeah, but I'm not connected actually. I just try to. Are you connected with it?
It's always deconnecting.
So I don't know how it works.
It's crap.
So maybe I should try the web chat.
Oh, are we already late?
I don't know. Is it at 15?
Supposed to 15. Yeah, so, okay, everyone. We're running a bit late because the last talk was a bit over time. Grab a seat and welcome our next speaker.
I guess you can just leave. Is it on? No.
That's bad because they can't. Should be. Hello? Is that working? Yeah. Cool.
Are you okay like that?
Yeah, I'll be fine. Okay, hi. I'm Nathan Hughes. I'm an undergraduate student at Aberystwyth University, and I'm currently on an industrial placement at the MPPC, which is the National Plant Phenomics Centre in Wales. And this is a project I've been working on. It's a open gravimetric phenotyping system, which essentially is an automatic system that waters plants and makes sure they don't die. So yeah, like I said, it's an automated system. It records biomass growth and water usage in plants. It records all its data automatically into a MySQL database, and it has the capacity to augment with loads of other cool sensors and that sort of thing, like temperature sensors, salinity sensors, that sort of thing. So one of the cool things I'm working on at the minute with it is automatically putting your data into a usable form so that the end user can see what's going on. This graph over on the right is water usage for a plant for the last 10 or so days. And it's really handy because you can see on day 4, I turned off the watering tap, and this let me know because I could see, oh, there's something missing. This is the web interface for everything that lets you change details on plants that are on your system. And yeah, it's all written in Python using WebPy. So the system as a whole is controlled with a whole network of Raspberry Pis. Oh, the pictures haven't come through great, but so in this one here on the left, you have a master Pi, which network boots a load of Pi nodes and SSHs into them, and gives hardware instructions of what to do. All of the control software is all written in Python, but the low-level hardware control is all done in pure C. And I think the big question is, why would you want a system like this? If you want to keep plants alive is the big thing. If you wanted to do any sort of research on plants and create data which is very accurate, and you don't want to stand there 24/7 recording things by hand. So yeah, people, also the other thing, you want an automated system because people make mistakes. So do computers, but they make slightly less mistakes, I would hope. Yeah. And also, you don't want to be there at 3 in the morning writing down plant readings. So some of you might know you can get automated systems, commercial systems that already do this and do it supposedly well. So why would you not just buy one of these systems? Like why am I working on this project? Why didn't I just, use a commercial system? And the reason is there's loads and loads of problems with them. I'm not going to name names or point fingers, but they're very, very, very proprietary, and that makes me very sad. So yeah, all of these commercial systems are generally, all the hardware's closed and all the software's closed, so we don't know exactly what is going on with the data that's going through the system. Yeah, and they're not adaptable. Our system's very adaptable. You can add on any sensors you want. You can get more data out of it. And especially if you're working in any sort of scientific environment, what you want to study today might not be what you want to study next week, and you don't want to have to spend a few €100,000 to change that. And also, whenever parts break, they're all proprietary parts that are all extremely expensive, whereas what we've done is very generic parts and easy to replace and modify. The other reason these proprietary systems terrify me is some of them will actually take data that you generate, and they will send them off to their remote server to store them, and then you don't really know what happens. So that creates all sorts of problems of, from as simple as if your internet connection cuts out, you can't access your data that was created in your greenhouse, because I don't know why they do this. It's a bit silly, really. And also, the reason I don't like not knowing what's happening to the data we're generating is because of this graph, and anyone who knows me will know I love to show this graph off. This is a load cell, so a scale with constant weights put on it, so 2 kilogram, 1 kilogram weights. And you can see over time, there's a load of fluctuations because hardware isn't very good at reading data for a long time, really. There's lots of noise. And the problem is on these commercial proprietary systems, you get straight lines back. You know what sort of averaging algorithm they're using, what sort of sanitization of your data they're doing, which is kind of scary, because then if you're using this for scientific research, you don't actually know what's happened to your data in this process. So that's why we've made this system, and we've made it really open, so that you have full control over your data and anything you're doing with it. And there's complete transparency on any sort of averaging we're doing, any sort of sanitization we're doing of data. And yeah, so we've made everything open, from specifications we've used for hardware to the software we've written. And I zoomed right through this talk super fast. I'm really sorry. So I'd like to say thanks for listening to me. Thanks to Aber University for having me, and thanks to a lot of people at the MPPC for helping me produce all of this work, and BSRC for funding it. And as I said, all of the source code's all on GitHub at the minute. Feel free to have a look, and yeah, if there's any problems, let me know, because I'd quite like to find some bugs in it. Any questions?
I'm coming with the mic.
Hello. Do you are you using any sort of well-defined data formats for exchanging, for sending the data around the system? So, for example, is there a common format that would already exist for communicating data about plants and moisture and things like that that you're using, or is everything sort of new and different?
Yes and no. I know there's quite a lot of, I think it's isotab formats they're trying to keep data organized in. And a few things like I'm not 100% on that. But I know they're trying to, but it's very unorganized at the minute. Yeah.
Hi, you said that the proprietary solutions are very expensive. I'm just curious, the setup that you've got going at home, how much did you totally spend on it?
How much have we spent on it? Well, there's been a couple of iterations of it, but I would say you're talking a tenth of what a commercial system would be. So whereas a commercial system, you might have spent upwards of a few €100,000, our system's definitely well under 100,000, probably quite a lot under. But I couldn't give you an accurate number, unfortunately.
Which sensors are at the moment deployed in your greenhouse?
What sensors? In the greenhouse, there's a lot of sensors. So we'll have air humidity, air temperature, those sorts of sensors. In gravimetrics itself, in its pure form, all we have is we have load cells, and yeah, it's pretty much just weight we're focused on for sensing at the minute. But there's a lot of capacity to add and augment more on, depending on what an experiment will want to find out, really.
Hello. So my question is related to the previous one. Did you also design the sensors like load cells, or did you buy them off the shelf?
No, at the minute they're off-the-shelf ones, but we've been looking into building our own to try and get more accurate readings and to play a bit more with what's actually coming out of them, because there's so much variation in. Because load cells aren't meant to be left on 24/7, there's a lot of tweaking you'd want to be able to do on the very low end of the hardware. So like that's on our GitHub at the minute. Well, some of our plans and some of the research we've been doing into the hardware side of how load cells actually work.
One more?
Me again. So, do you have an API for this data, or can it only be accessed through a web interface? And did you think about using something like Grafana, for example, so you don't actually have to write the plotting and website, so you just bothered about data collection?
I think your mic just stopped working, so I don't know what happened. But, yeah, it's off, or
I think so.
yeah, it's not working anymore. So maybe his mic is not working anymore. So if you have more questions, then you just meet him outside. Thanks a lot for your talk.
Oh, really? Oh, amazing. Thank you. Sure. Thank you very much.
Is it your water?
No, this is.
Okay. I don't know if this is our mega collection.
Cool.
No member stick or anything.
I've got it.
Needed it. Computer.